which we have seen before, the vertical asymptotes are what makes the bottom 0. And when we were looking at those, we were talking about continuity. I'm going to speak. Excuse me.
Yes.
Thank you. When we were talking about continuity, those were the places where your limit went to positive infinity or negative infinity. And then yesterday we talked about a horizontal asymptote. And so to find that, we had to do the limit as x approaches positive and negative infinity. So we're asking, as x goes off forever, in the positive direction and the negative direction, are we approaching a number? With that, you're welcome, have to check both. You might get the same answer both times. In fact, most of the time you probably will. But it is possible that you will not. So that's why we did one example yesterday where they came out to be 2 different numbers. And I told you that's why I make you check both directions. Okay, so let's look at this one. I'm asking you to find the limit as x approaches positive infinity here. If I just plug infinity in, I get the square root of infinity minus infinity. Does that mean anything? Do I know what that's going to? No. The one new piece we had yesterday, we decided that if you have a number divided by infinity, that would turn into 0. Remember we talked about like if it was 1 over x. 1 over 10 is 0.1. 1 over 100 is 0.01. 1 over 1,000 is 0.001. As that x gets bigger, that thing's getting smaller. In this case, though, we don't have any rule about what we can do. So, think back to other problems we've done. When we had radicals, what is a strategy we have what have we done? Yes. So think of that as over 1. And we are going to multiply by the conjugate on the top and the bottom. So if I FOIL the top, square root times the square root, that radical drops. The plus and the minus cancel, and we have minus x squared. On the bottom, 1 times anything is just that. We can simplify the top. The x squared drops, so we have 1 over. So at the beginning, if we just plugged in, we had an infinity minus an infinity, and we couldn't figure out what that went to. Now if I look at the bottom, I have the square root of infinity squared plus 1. If you take a really big number, you square it, you get a really big number. If you add 1, it's still a really big number. If we take the square root, it's still a really big number. And if you add another really big number to it, we're still just getting a big number. So this is really just turning into 1 over infinity. The difference is when it was subtracted, we don't know what infinity minus infinity is, but if it's adding, if you add 2 really big numbers, you still just have a really big number. So then we said before, 1 over infinity is always going to turn into 0. You take 1, if I have 1 pizza and I divide it in our class, you each get a slice. If I bring in Mrs. Dyer's class, then we have to cut our slices in half. If I bring in Mrs. Keller's class, we have to cut them in half again. The more people we add, the less each person gets. It's going to 0. Does that make sense? So we're basically just trying to get these to the point where it's 1 over, or a number over infinity, and then we can finish it off. I'm going to skip this one actually. Haven't done a lot of the trig functions, so I'm going to skip that one. have the limit as x approaches negative infinity of e to the x. So we're trying to get to the point where we can plug this in and figure out what it's going to turn into. Right, if I just plugged in my negative infinity, what does a negative exponent do? Flips it. So this just becomes 1 over e to the infinity. Okay, what happens if you take e to a bigger and bigger and bigger power? Yeah, this e to the infinity is just going to infinity, right? It's just going to get bigger and bigger. If you take a number, let's think about 2 for a second. 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth. It's getting bigger as that power gets bigger. What does 1 over infinity turn into? 0. I want you guys to take a second and look at this one, see if you can figure that out. What do you think it goes to? Nobody's brave enough to guess? Alright, let's see. Can you just plug in 0? No. But we are coming into 0 from the left. So that means you are taking 1 and dividing it by a smaller and smaller negative number. So, 1 divided by negative 1 is negative 1. If you do 1 divided by negative 0.01, you get negative 10. If you divide by negative 0.001, it's giving you negative 100. So what is this power turning into? Positive or negative infinity? So this whole thing, if I'm approaching 0 from the left, I'm getting e to a smaller and smaller negative power. Sorry, a bigger and bigger negative power. We know a negative just puts it on the bottom. So you just have a number divided by infinity, which is 0. How can we check these? What other skills have we done for finding limits that we didn't know? We've looked at graphs, we've made those tables. We're just trying to get away from that if we can and just reason through some of these. But when you're confused, take a second and stop and look at the graph and see what it gives you. Okay, that option is still available to us. Any questions there? Let's look at this one. All right. What happens? What is the graph of sine? What does it do? Yeah, it just bounces back and forth between negative 1 to positive 1. As x goes on to infinity, does it ever stop bouncing? So does it approach any one number? No, so this one does not exist. You don't have to have a limit. The only time we're getting a limit is when there's a horizontal asymptote on our graph. Otherwise there isn't one. Okay, we are going to take a little detour. I want you to get a partner, and I just posted a handout on Classroom. So let's talk about these and see if we reasoned correctly. You could just start plugging in numbers and seeing. Also, if you are approaching 0 from the right, you're putting in a positive number. So does the absolute value change it? No, so it's just like x divided by x, which is 1, so you get 1 out. If you approach from the negative side, then the absolute value makes it the opposite of that, so you're getting out negative 1. Are we good with those two? Try working through the next set then. So this first one, if you plug in 7, the top is turning into 7. The bottom, if you just plug in 7, you're getting 0, right? In general, you're going to be getting a really, really small, either positive or negative number, depending on which way you're approaching from. But once you square that, it's going to be positive. So the bottom is approaching 0, but from the positive side. So what would be 7 divided by a smaller and smaller positive number? Okay, if you guys looked at the, oh, did I skip 6? Sorry. If you looked at the graph on this, it looks something like that. There's a row of asymptote 7 and both sides are going to infinity. So on this one, the top is going to 7. Okay, the bottom, we have x squared minus 49. So we could factor the bottom. Okay, 7 plus 7 is 14 times, okay, 7 minus 7 is going to 0. But if I'm approaching from the right, I'm putting in something bigger than 0. So it's approaching 0 from the positive side. Is everybody with me?
How do you get 14?
I
Yeah.
plugged in at 7 right here. 7 plus 7.
So you plug it in unless it equals 0.
Right, and then I have to stop and think about it. So we're just trying to get to the point where we don't have to make a table every time we have a limit we can't work out. So we're trying to reason our way through them. So the bottom, anything times 0 is going to 0, right? So you have a number divided by a smaller and smaller positive number. What's that going to? Infinity. So basically, if you have a number divided by infinity, it goes to 0. If you have a number divided by a 0 to the left or 0 to the right, it's going to positive or negative infinity. Okay, if you looked at the graph here, again, you've got a vertical asymptote there. And so you can check it's going to go up forever. All right, let's look at this one. If I just plugged in, the top is 5, the bottom is going to 0, but I'm approaching 3 from both sides. If I put in something bigger than 3, it's approaching 0 from the right. If I put in something smaller than 3, I'm approaching 0 from the left. So from the right, this should be going to positive infinity. From the left, it should be negative infinity. So does the overall limit exist? No. So this one does not exist. If you looked at the graph on this, it is going to look like this. So we can see you've got the ends going opposite directions. So the limit doesn't exist. What if I throw a square on the bottom though? So now the top is still going to 5. The bottom is still going to 0, and it may be from the positive or the negative side, but once you square it, it's always positive. So if you have a number divided by a smaller and smaller positive number, it's going to infinity. Does that make sense?
I don't really get how you get the 0 from the right. Like,
Okay.
I don't know.
So we're approaching 3. So if you put in like 2.9, 2.99, 2.999, when you subtract 3, you're getting smaller and smaller numbers. So it's going towards 0. Because I'm squaring, I know that number will be positive, so that's why I have my plus. last question. Let's graph this piece, guys. So my breaking point is 3, so we have to plug that in. So if I put a 3 in the top, 3 squared is 9, minus 5 is 4. It had an equal to, so closed circle. Then I want x less than that, so if I put in a 0, then you get 0 minus 5, which is negative 5. You could put in more if you wanted. You know, if you put in like a 1, you get negative 4. If you put in a 2, you get negative 1. So what we have here is just part of a parabola. If you put in like negative 1, you get negative 4 again. And it keeps going that way. The second piece, we have to start with 3. We put in 3. 3 plus 2 is 5. That would be open. Then you need things greater than that. So if you put in a 4, you get a 6. If you put in a 5, you get 7. So it's a line going that way. Okay, so we can use this graph to help us, and we'll also talk about using the equation. As you approach 3 from the left, if I'm looking at my graph, I'm coming in this way, and what value is it approaching? 4, isn't it? If you're coming in from the side smaller than 3, you're on this parabola piece, and your y is going to 4. If you wanted to do that without taking the time to draw the graph, 3 from the left, you're smaller than 3. So which piece should you be on? The top or the bottom? Top. So if you plug a 3 in there, 9 minus 5 is 4. As you approach 3 from the right, bigger than 3, which piece would that be? The bottom. 3 plus 2 is 5. If I looked at my graph, if I'm approaching bigger than 3, I'm coming in here, my y value is going to 5. So overall, at 3, does not exist. Those pieces don't meet. It's a discontinuity at 3. So we don't have a two-sided limit there. Okay. Questions? Let's go back to our notes then. So I want to just practice some more limits at infinity. So I have the limit as x approaches infinity of x cubed. So if I just plugged in, you get infinity cubed. If you take a really huge number to the third power, what are you going to get? An even bigger number. So that's just approaching infinity. B, I did a negative infinity. If you take a negative number and cube it, what are we going to get? Negative infinity cubed is just infinity. If you think about x cubed, does this match up? X cubed is like our chair. As x goes forever in the positive direction, it's going to infinity, and the negative direction is going to negative infinity. So we can get it from a graph or just by kind of reasoning through it. Let's look at this one. Okay, so approaches infinity of x squared minus x. In general, if it's infinity plus infinity, that goes to infinity. If I add two really big numbers, I'm just getting a bigger number. But if I subtract, I don't really know what's going to happen. Sometimes it might go to 0, sometimes it might still be going to infinity, sometimes it might be going to some number. We don't have the rules to help us with that. So we had one earlier like that, but it had radicals, so we multiplied by the conjugate. I don't have any radicals here. So let's see if we can reason through this. Is there anything you notice about x squared minus x? All right, let's take out that x. If you plugged in now, this is infinity times, what happens if you take a really huge number and you subtract infinity, or subtract 1? It's a little smaller, but if I have like 10 billion minus 1, does that minus 1 really change it much? No. So we're really ending with a really big number times a really big number. So my answer is a really big number. So even though we couldn't necessarily look at infinity squared minus infinity and know what happens, if we factor it, if you're just taking infinity minus a number, that doesn't change it much. So we still are just multiplying two really big positive numbers, so we get a really big positive number. Right. Let's do okay. What was the strategy we had yesterday? When we had those fractions, we were getting infinities on top and bottom. What did we do? We divide everything by the highest power of x. What's the highest power of x here?
X squared.
Okay, so if I divide everything by x squared, or we can think of it as multiplying by 1 over x squared. Then we get 1 minus x over x squared is 1 over x, over 3 over x squared minus x over x squared is 1 over x. Okay, we did that because then we knew anytime we had a number over infinity, it went to 0. So right now I have 1 minus 0 over 0 minus 0. Did that help? No. Why not? We still have 0 on the bottom. So we tried doing it like yesterday. We have a problem though because I'm just getting zeros on the bottom. So what you can do, if this ever happens, we are going to back up. And let's try, instead of multiplying by 1 over x squared, let's try just 1 over x and see if that helps. So x squared times 1 over x would be x, minus x over x is 1. 3 over x minus x over x is 1. If I plug in now, I get infinity minus 1 over 0 minus 1. Infinity minus 1 is still a really huge number, divided by negative 1. So this is going to give me a negative infinity. So sometimes you try something, it doesn't work, you have to try something different. Okay, don't get discouraged just because it didn't work out the first time. Keep trying. All right. Let's see. I would like to do, okay, I'm going to skip next example. I'm going to do this 1 and 2 that I have on here, and then we're going to stop for today. So, this one, what could our strategy be? Like the last one.
Take out the biggest.
divide by the biggest, so that's x cubed, so let's multiply by 1 over x cubed. So then we have 1 over x cubed plus x squared over x cubed would be 1 over x. 2x cubed divided by x cubed would just be a 2. X cubed over x cubed is 1. 5x squared over x cubed is 5 over x. Minus 3 over x squared. Minus 5 over x cubed. Okay, anything with an x on the bottom is going to turn into 0. And numbers just stay, just constants, don't change. So what do we get?
2.
Last one. There's a couple homework problems that ask you to draw a graph, so I wanted to try one of those together. So if you would open your book to page 140, I want to look at problem number 9. So you have to draw a graph that meets all of these requirements. I intentionally picked one that had a lot more requirements than any of the graphs I'm giving you. So I'm doing probably the hardest one out of this. So let's go through the requirements and see what it says. First thing, f of 0 equals 3. What is that? What does that mean? F of 0 equals 3. When x is 0, y is 3. That's just a point on my graph. The limit as x approaches 0 from the left, so as I'm coming in from this side, we're getting 4. Okay, now can that be a closed circle here? No, it's got to be open because it's got to be a function. No, I don't know much more about this, so it may just be a horizontal line. I may have to change that as I read more directions, so don't draw that in too dark yet. We don't know for sure if that's going to work. I'm just kind of adjusting my graph as I go. The limit as you approach 0 from the right is 2. So as I'm coming in from this direction, it's 2. Again, I might need to adjust this, so just lightly sketch it in for now. The next one. The limit as x approaches negative infinity, so as we're going forever in this negative direction, it equals negative infinity. So what does my graph need to be doing? Going down. Now, you can adjust this and make it just like a parabola going down. We could just make it like this. There's nothing that says it's, not a piecewise function where we might have something like that. The limit as you approach 4 from the left is negative infinity. So x approaches 4. This is like saying we are going to have an asymptote here. And this section has to be going to negative infinity. So I might need to adjust this a little bit. That part's going down forever. As you approach 4 from the right, it's going to positive infinity. So this section's got to be going up forever. And as you go to infinity, so as we go forever in this direction, my y is just approaching 3. So that means like 3 is a horizontal asymptote here. So it looks something like this. Now, there's more than one correct graph for this. You just have to make a graph that meets your requirements. So what I would recommend on those after you draw your graph, go back and read all the requirements one more time and make sure everything matches. So, the assignment printed on here, I told you yesterday, I'm kind of modifying that a little bit. We are not doing problem 11. Problem 13, you don't have to list the properties. Okay, I think otherwise I'm going to keep it. So, tomorrow is a work day. All right, we're done with the section. You have the whole class tomorrow to work on it. I know I had you